Good day, friends. Right now, let's try to solve this problem. A heavy object is held by friction between two horizontal rods A and B. What must be the distance from the center of gravity of the object to the point of contact with rod A so that it cannot slip out of its support? The distance A, the angle alpha, and the coefficient of friction K are given. Okay, so if we imagine it, this is some, let's call it some stick, right? This whole thing. And if we look from side, it must look something like this. These two are rods. In three-dimensional case, it would be something like this. Which means that one of them is below, one of them is above, and this thing is not being rotated, this thing is not moving. In fact, it tries to slip to this side, but there is a friction here and here that is not allowing this object to slip out. Okay, good. Right now, let's make some analysis to solve this problem. We need to find this distance. Yeah, let me note it with green one. We need to find this distance to a rod and the center of mass. Let's call it some x. Okay, good. And right now, let's draw forces that are acting on our object. Yeah, long object. Let me take this a little bit far so you definitely understand that this A is just the distance between A rod and B rod. That's why. Let's draw force like this. So this force is acting with a normal force. And here we have one more normal force. Let's call it N1 and N2. Some people might ask, why is it so? Because we are working with this rod. We're interested in this. And if we're trying to think from the perspective of this long rod, then this one is pushing it upward, and this one is trying to push it downward, as you can see. And also there are some more forces like mg. Let's call it mg. Yeah, and definitely we can break that into components. Like this one and this one. You definitely know that if we continue this thing, it has to be 90 minus alpha. This thing has to be just alpha itself. That's why this thing will be what? This thing is mg cosine. This thing is mg sine. Okay, one more thing to note is that there are also frictions which are holding our object to not slip away. So this is, let's call this friction force 1, this is friction force 2, where we don't know anything about these things, their materials, their parameters. That's why we cannot say that their frictions are equal to each other, their normal forces are equal to each other. We cannot say such things, okay? Good. If you understood this part, that would be pretty much intuitive. This thing stands in equilibrium. That's why we know that automatically that sum of forces equals to 0 because this thing is not moving. And sum of torques also is 0. Why? Because this thing is not being rotated as well. Good. Okay, let's think about torque right now. Yep. Let me put some pivot in here. I don't know, but I'm interested in here. This thing would be my pivot. Oops. Yeah, this violet thing. So, which means that this force N1 is not important right now. Yeah, we're not interested in it because it's passing through exactly from the pivot. Its distance is just 0. But these two things, this is already perpendicular, this thing is already perpendicular. Both of them are trying to rotate different sides. Let's call this one torque 1, this is torque 2. As you can see, torque 1 is counterclockwise, torque 2 is clockwise. They're equal to each other because it's not being rotated. The sum of torques equals to 0, so it must be something like this. Torque 2 minus torque 1, because torque 2 is clockwise, torque 2 is counterclockwise, but their sum is equal to 0. That's why we know for sure that torque 2 equals to torque 1. Yeah, and then if we open that up, that would be F1 R1 equals to F2 R2. Okay, good. And what are the forces? The force of torque 1 is mg cosine alpha, and the force of torque 2 is N2. Okay, good. This would be mg cosine alpha, here equals, and here we have N2, normal force 2. However, what are their distances? The distance of mg cosine alpha from that pivot is exactly what we are searching for, it's x. And the distance of the normal force 2 till the pivot is a. Right? So here we need to write, this would be x, this would be a. Okay, good. And what we're trying to search is this thing. Okay, let's derive its formula. This thing below would have mg cosine alpha. Above, it would be N2 multiplied a. And, okay, that's good. We are given with a normal force 2. We don't know its meaning yet. mg cosine alpha. Alpha is given. Pretty good. G is a constant. The mass was not given. It was not said anything about the mass. So I will just suppose that this mass has to be annihilated somehow. It must be just cancelled with some other mass. Okay, but right now, let's try to think further. Let's write down these sum of forces equals to 0 equations. Let's write first it to the horizontal one. So I would take my system of coordinates like this. This would be my vertical. This would be my horizontal. Yeah. Horizontally, we have mg sine alpha and two friction forces which are opposing it, and this thing is not moving. The sum of forces equals to 0. That's why it would be automatically mg sine. Okay, let me write it here. X mg sine alpha equals friction force 1 plus friction force 2. Some people might ask me why, but in fact, as we have told you, all of the forces, the sum of them must be 0. This thing is against, this thing is against, and the result had to be 0. But if we move this thing and move this thing as well, those two will become positive. And that's why I'm writing it like this, okay? This is equal sign, this is not 2. Yeah, I'm sorry. Right. If we open that up further, we know that this is coefficient of friction n. This is the last moment where it tries to slip, but it's not slipping yet. That's why we can write it for kinetic friction coefficient. Why? Because this just tries to slip. This is the last moment. It starts to become kinetic friction, but it didn't start yet. So it's still equilibrium. At the same time, we can apply kinetic friction coefficient. This has to be Kn1. This has to be Kn2, right? The K is the common factor. That's why it would be out of the bracket. And inside we would have something N1, N2. Okay, good. Good. Let's write down here for Y. Yeah, vertical axis. Vertically we have here N1, N2, and mg cosine alpha. This would be the very same principle. So, this thing has to be mg cosine alpha equals just N1 itself and N2 itself. The very same principle. Oh, no. I'm so sorry. mg cosine alpha plus N2. Yeah, because they are trying to pull downward and N1 is opposing them. So that's why it would be mg cosine alpha minus plus N2 equals N1. Yep, right. N1 is trying to push upward. mg cosine and N2 are trying to push downward. Okay, good. Okay, what we are going to do right now is very important. Let's give some meaning to N2. Yeah, because we have N2 here, and also we must have some meaning of N2 here. Let's substitute N1 with N2, right? So we move this K to that side, and we move this N2 to that side. So from the first equation, x direction, we would have something like this. N1 has the meaning of mg sine alpha divided by K, it minus N2. Good. We right now can put it in here to the first equation, and to the second equation, and then we would have something like this. mg cosine alpha plus N2 equals mg sine alpha divided by K minus N2. Yeah, right now we can move both N2 to this side, N2 to this side. This mg cosine alpha goes that side, and then we would have as a resultant something like this. This thing had to be 2N2 equals mg sine alpha. Okay, mg goes out as a common factor, right? Here inside we would have sine alpha divided by K minus cosine alpha. Okay, something like this. Good. But if we continue a little bit further, then this 2 goes down, this 2 goes here, and then we would have something like this. mg divided by 2 and everything inside. Okay, right now we can put it in here. Here we have still a mg cosine alpha, but here, instead of the N2, we can put here mg divided by 2, mg divided by 2, and also here, this thing would be sine alpha divided by K, sine alpha divided by K minus cosine alpha, if I'm not mistaken. Yeah, good. What else? Right now we can see that this mg goes out, this mg. Okay, and the meaning of x would be something like a divided by 2 here. We have cosine, yeah, we can move cosine inside. We can move this cosine inside of here and also below cosine alpha. Then the cosine alpha would go inside as sine alpha divided cosine alpha. So yeah, so you don't get distracted. Let me write it directly. Yeah, it would be something like this: sine alpha divided by cosine alpha, and also here 1 divided by K. K is still there. Here this thing would be cosine alpha above and also cosine alpha below. Why? Because it was above, this thing came to below. Okay, right now this thing would be 1. Sine and cosine gives us tangent, so this thing had to be a divided by 2. Here we would have tangent alpha divided by K minus 1. Okay, and if we just give that meaning, this would be a divided by 2, and also this thing inside would be what? Tangent alpha minus K. In totality, this had to be K in here, but I can move this thing out, put it here, and then I can just move this thing a little bit here. And that would be our final answer. A divided by 2K, and in the brackets tangent alpha minus K. That would be our answer for X. And are we given with all of those numbers? I believe yes. We are given with distance A, which is in our answer. Also alpha, it is in tangent. And K, coefficient of friction, which is also in our answer. As you can see, A, K, and alpha. Again, K, 2 is a constant number, and everything is in our answer. Okay, I hope it was understandable to you. I hope this was pretty clear, but if it is not, you can write me privately. Thanks for your attention.